Welcome, everybody. It's my great pleasure to host the last session of our live Theory Lab 2020 today, together with Miriam Sander. Our final speaker in this short lecture series is Professor Ulman Lindenberger. The lecture series was organized jointly by the International Max Planck Research School on the LIFE course, short LIFE, and the Center for Lifespan Psychology at the Max Planck Institute for Human Development in Berlin. As throughout the whole session, we are joined by our live fellows, Anna Thoma, Lisa Ralber, and Colleen Frank today. As is good tradition in the live graduate school, our speaker will be introduced later by Lisa Ralber. I also welcome Thorsten Pachur, one of our co-moderators throughout the sessions here. Some short announcements. As the session is recorded for later use on YouTube, we would like to ask everybody who does not want to appear on the recording to switch off the microphone and the camera throughout the whole session. As we have done in the previous lecture sessions, also today, after the introduction by Lisa Ralber, we will have the talk by Professor Lindenberger. We will postpone all questions for after the talk presentation. You can use the questions panel on your go-to control panel to ask questions, to pose questions, and Miriam Sander will create the questions, and we will have a question and answer session after the presentation. So from now on, please keep your microphone muted so that you do not have any interruptions on the auditory side for the presentation today. And now I would like to ask Lisa Ralber to introduce Professor Ulman Lindenberger.
Thank you, Markus. I have the pleasure to introduce Ulman Lindenberger, who's the speaker of the research school that also hosts this theory lab we are taking part in right now. And throughout my time within the International Max Planck Research School on the LIFE course, short LIFE, I once or twice got to know the passion with which Ulman Lindenberger engages with topics concerning human development over time and how to think about the concepts of change. And his research interests include behavioral and neural plasticity and brain behavior relations across the lifespan, as well as lifespan development theory and the methodological aspects of longitudinal research. He studied and received his doctorate and habilitation from the Free University of Berlin in psychology. And in 1999, he became a professor of psychology at Saarland University, and has been a honorary professor of psychology at Free University of Berlin, Humboldt University of Berlin, and Saarland University since 2003. Among many other memberships and positions, he's also a member of the German National Academy of Sciences, Leopoldina, and just recently he became vice president in the Human Science section of the Max Planck Society. Congratulations again. You can contact him via the website of the Max Planck Institute for Human Development, short MPIB. And this is also where you can find more information about the many projects he's involved in. Regarding social media, Ulman Lindenberger is not himself active on Twitter, but he is mentioned there quite regularly if you feel like you want to read about it there. And now I'm looking forward to Ulman Lindenberger's talk on why we need a lifespan approach to developmental change. Thank you for joining us today.
Lisa, thank you for this very kind and gracious introduction. Of course, you now made me curious what's been written on Twitter about me, but I will resist and not take a look for sheer reasons of time economy. But of course, it's worth a thought what's going on there. Okay, let me activate my presentation. I hope this will work. Do you now have the full screen view?
We have the full screen view. Looks good.
Okay, so I can start. So it's a pleasure to speak. I just want to find a way to minimize the. Yeah, perfect. But now I'm okay. It's a pleasure to speak as in the context of this series, and what I would like to comment on in the next 45 minutes, 50 minutes or so is why I think a lifespan view on behavioral development is useful and the ways in which it is useful. I then will talk about individual differences in change, which I think is a specialty of the lifespan approach. I will give an example, namely coupled cognitive change in adulthood and what I call dynamic de-differentiation. Then we'll notice some future challenges, just to remind us that the tasks are all difficult and wide open, that we are not done yet with the study of behavior across the lifespan, and then end with a few concluding remarks that will take a little bit more time than usual, but I think I hope it will be worth it. So let's start with a classical definition of development, or what you might call the narrow definition. There you would say that behavioral development, or what qualifies as behavioral development, is a sequence of stages or levels or phases that are irreversible, age-based, and universal, sometimes also labeled as natural, that moves towards a superior end state, where the changes are qualitative in kind, and where the earlier stages are prerequisites for the later stages. And the classical example for such kind of a theory would, for instance, be Jean Piaget's theory of child cognitive development. And I think what's important about this is you may think that I'm giving you a caricature, but actually such a kind of theory is a very precious thing, because it makes very strong statements about what should evolve in what sequence and for what reason. If we now go to the lifespan extension of what is considered behavioral development, you will notice lots of conjunctions, I would say. So we think that development is cultural and biological, and that and actually stands for an interaction rather than a juxtaposition. It's universal and variable. It is qualitative and quantitative, and I put a question mark here because if you push me on that notion, you will find out that it's actually not so easy to distinguish what is qualitative and what is quantitative. It is composed of gains and losses. Losses are part of behavioral development. It's plastic, but also constraints. So it's plastic with the limits. It's selective and locally adaptive. It doesn't follow some teleological end state, but always tries to solve problems on the spot. It's goal-directed, so we are goal-directed agents, and accidental. Things happen to us. And again, if you push me on that distinction, I will have a hard time defending it, but I think it's part of the overall landscape. It extends from conception to old age, and it can be thought of as a superimposition or interaction of evolutionary, historical, and ontogenetic processes. As a consequence, behavioral development is multidimensional, multidirectional, and multifunctional. You may perhaps then try to put some more structure to this big list by saying that lifespan changes in behavior need to be understood as interactions among mechanisms related to maturation, learning, and senescence, where none of these meta mechanisms is restricted to one part of the lifespan. So you may still have maturational processes going on in adulthood. You may have learning taking place over the entire lifespan, and you may have senescence gaining importance late in life, but you can also find senescent processes early in life. Lifespan theory and methodology needs to integrate evidence across domains of functioning, timescales and levels of analysis. And we also think that the exploration of age-graded differences in plasticity or change in change is a powerful tool to probe the system, to identify mechanisms of development. And what you may think of as development is that there is a probabilistic landscape to all of us. So this, what you see here, actually could describe a single person and its potential trajectories across life. And then the question is, what are the mechanisms that move this person around as far as its actual trajectory is concerned? Now, does lifespan psychology, the way I just defined it, actually constitute a theory? I would say it does not. This is not a theory. Rather, I would say lifespan psychology provides a framework for thinking about the overall landscape of human behavioral development. That is, it tries to represent the problem of understanding development in all of its complexity. And then I would say offers an antidote against conceptual oversimplification. So it reminds us to know what the full set of possibilities is and how complex development actually is, human development actually is. To be scientifically productive, I would say that lifespan psychology needs to get in touch with theories about specific developmental phenomena. So the lifespan framework in itself, in and of itself, is too general to really produce positive knowledge in the sense of finding out about how things work in a particular domain. But it may help to avoid shortcuts and reductions that may occur otherwise. And I think a beautiful example was, for instance, Lars Lieberg's talk that is informed by a lifespan perspective and then tries for the domain of memory to specify what the mechanisms are, what the relevant individual differences are, what the consequences are, the antecedents are, and so on, that lead, in this case, to brain maintenance and memory maintenance in old age. Another element I would say that was prominent among all the speakers of the series was the emphasis on behavior, and I will come back to that. So experience as a product of an ongoing reciprocal interaction between the environment and the brain that puts behavior in a key position because it is influenced by the brain and influencing the brain, and it is influenced by the physical environment and influencing that environment. So I would argue that without putting behavior in a very privileged position, you will have a very hard time understanding how the brain evolves and why it evolves. And we had this beautiful example of cascading critical sensitive periods in the domain of language, for instance, where one critical period builds on the other in an orderly fashion. And we had Chuck Nelson asking the question, can we figure out ways to rescue critical periods in adulthood? And are critical periods limited to the first years of life? And I focus on this because it gives me a good opportunity to give you an example of what I mean by a lifespan approach. What we are currently trying to do is we are looking at human skill acquisition in adulthood and are trying to identify the mechanisms that enable plasticity in adulthood. And what we think is happening is that there is an initial expansion of the neural tissue because the brain is not able to represent the problem at hand with an exploration of possible circuits that then consolidate such that most of them are pruned away again and are selected and then refined. Now, when you look at this, you may notice that it actually does have some resemblance with the plasticity processes that go on in critical periods. And what we think is extremely fruitful is to take phenomena across the entire lifespan, such as plasticity, and to look for their commonalities and for their differences, instead of having a field of child development that looks at critical period and a field of adult development that looks at skill acquisition without making contact to one another. And of course, making contact to one another is extremely facilitated by the use of adequate animal models. And it's really a big pleasure to see how, for instance, people like Takao Hensch, who are working on the mechanisms that govern critical periods, make contact to the work that goes on in plasticity during later phases of life. Here's a slide from Gerd Kempermann, who noted that causality runs in both directions. It runs from the genes, if you wish, to behavior, but it also runs from behavior to the way genes are expressed and to the way systems are organized. So by putting behavior in this pivotal position, we also avoid a situation where we can study what the neurons are doing, but we don't know why they are doing it and what's the functional value. The functional value we get only by looking at the entire organism and the behavior that it is emitting. I was pleased to see that you can take this approach even to the study of machines, as Iyad Ravan was showing in his talk, where he took typology that was developed by Tinbergen, among others, for the study of animals, and tried to see what happens if you actually try to look at machines and at the programs on which they operate, as if they were emitting a behavior, and basically studying a new tribe, the tribe of machines. So that was for an introduction where I see the value of a lifespan approach, basically charting the full complexity of the phenomenon and then trying to become more specific whenever you approach a particular problem. I now would like to briefly focus on individual differences and change and how difficult it is to actually study change. There was this wonderful quote from Baltes et al. That Ellen put into her talk. Typically, inter-individual differences at a later time are cumulative results of previous intra-individual changes that differ across individuals. That means the key to understanding between person differences at any given point in time is actually to understand earlier differences in within person changes. So whenever we control for between person differences, we actually control for a part of development. What this means is that we somehow need to find a way to link what's going on from moment to moment, or what John Nesselrode called variability, to what's going on over longer time scales, or what John Nesselrode referred to as change. So we need to link the momentary processing dynamics at the neural level to those at the behavioral level and to the way in which they affect the environment and are affected by it. And we need to do this in such a way that we understand how cumulatively over time we get to these stable between person differences. And that's a very, very difficult task because it requires us to link things that are not easy, but the linking operations are notoriously difficult. What this means is that the privileged unit of analysis, if you think about it, is really the individual developing person. That's, if there is a privileged system, then it's an individual developing person. And then we try to kind of build up the commonalities and the differences in development between these persons by aggregating or by comparing what's going on within each person. And whenever we take between person differences as a proxy for within person changes, we know from the outset that this is actually in principle wrong. It may at some occasions be the second best thing to do. So I'm not saying that we shouldn't do it, but whenever we do it, we should do it with caution. What makes this task difficult is that people differ from the outset. So we know that dizygotic twins grow less and less similar to each other as they age, whereas monozygotic twins remain highly similar to each other. And as a consequence of the dizygotic twins growing, becoming more different from one another, and the monozygotic twins remaining more similar to each other, the heritability of cognitive traits goes up with age. Another way of putting this is to say that people are not randomly assigned to lifestyles. Probably the monozygotic twins remain similar to one another because they select into more similar environments than the dizygotic twins. So whenever we have longitudinal studies that suggest that leading an intellectually challenging, physically active, and socially engaged life may mitigate losses and consolidate gains, that is whenever we interpret this as something that the environment imposes on people and makes them fitter or more active in old age, then we should keep in mind that we actually don't quite know whether this is true because people chose different environments in the first place. So what we really would need to do is to go beyond this dichotomy of causation versus reverse causation. Was it already endogenous to begin with, or was it really a function of the different environments, to what you might call dynamic models of emergent individuality, where we understand the recursive relations between environments and genetic differences. There is one particularly useful way, I think, of dealing with this problem, that is to go into existing longitudinal studies, then randomly select intervention groups from these existing studies, do whatever you think should have certain effects on certain people, in cognitive intervention, a physical fitness intervention, feed them back into the longitudinal panel, and then observe long-term predictors and outcomes. Because this way you have basically both parts of it. You have both the long-term change in the wild, so to say, and you have the experimental control of having run an experiment and seeing what it does to people. So that's, I think, an ideal design that should be used more often. Alan Hamaker also talked about the problem that sometimes the average curve may not represent anybody. This is an old thought example from Baltus and Labouvi, where you can see the average trend, and the average trend is a mixture of people dying at different ages and basically having a plateau followed by a terminal drop, and then you get a smooth curve that is not representing anybody. This is just based on a thought example. We actually ran a study on model misspecification in adult cognitive development. And we asked a very simple question, I would say, namely, if we fit developmental data, and in this case, I'm talking about long-term cognitive change, to the wrong function, will we ever notice? So what we did is we simulated data with an exponential decline function based on conceptual consideration of available data. That is, we assumed that people typically develop through adulthood and old age in a way that is well described by an exponential function. We then performed simulations following a longitudinal sequence design. That is, we sampled from these trajectories as if we had a longitudinal sequence where people are observed at different ages, and where you have people starting the study at different ages. And then we analyze the data with a linear latent curve model, a quadratic curve model, which has both a quadratic and a linear trend, and the true exponential model. And the simulation parameters were the reliability of the graph course, the sample size, the number of repeated measures, it was 3 or 6, and the interval width between measurement occasion, 1 year, 2 year, 3 year, 4 year, 5 years. I'm not going into the details here. This is just to give you an idea of how these curves look like. So we had the lower 3 panels show you a situation with a stronger exponential decline. The upper show you one with a shallower exponential decline, and going from left to right, you see more and more reliable growth curves. I think the most reliable had a growth curve reliability of 0.91, which means that the measurements at each time point were taken with high reliability. The main results: first, the quadratic model lacks statistical power. If a change process is exponential in nature, but analyzed with a quadratic model, individual differences in change often go unnoticed. Second, if we do detect variance in change with the quadratic model, we are very likely to obtain biased estimates of individual change scores. That is, the individual differences that we capture by the quadratic model, when they are statistically significant, do not correlate highly with the true individual differences as based on the exponential growth. So the model is not wrong but useful, it is wrong and wrong. Goodness of fit indices fail to discriminate between quadratic and exponential models. So we would, if we just would be fitting our quadratic models all the time, we simply would be happy with it and think, wow, I have a great fit to my data. What this means is that we may often be fitting the wrong and not useful longitudinal models without actually noticing it. And what this means, I think, is that we need conceptual considerations that guide us in selecting the shape of change at least as much as considerations of fit. And polynomials are not something that you will find in nature all too often, whereas exponential functions is something that you find across all manifestations of the living world. So it may be good to try to use shapes of change that actually have some physiological or biological meaning, instead of just blindly relying on good fit indices. The second methodological point that I wanted to make is about the continued use, and I know people who know me, they will say, okay, he does it again, the continued use of cross-sectional data set to make statements about the dimensionality of change, which is simply something you cannot do. So what you see are all kinds of flavors of mediator models where you partition variance in Y such that you get at the shared component of predictive variance of age and X over the simple effect of age. And this then allows you to make statements of the sort, I quote, 80% of the individual differences in complex cognition are accounted for, 80% of the age differences in complex cognition are accounted for by individual differences in perceptual speed, white matter tracts, cortical volume, what have you. So that you then portray the variable X as the proximal cause of age differences, but you really mean age changes in Y. So you behave as if, based on a cross-sectional scenario, you could gain knowledge about what are the drivers of development. And this is simply impossible. And it's very easy to see that it's impossible. Imagine one variable and you do have the changes in that variable. And then you observe this variable only once. And that's what you have. And now imagine you do this for another variable. So what you have are just two kinds of snapshots, for one variable and one for the other. But of course, you lack the way they are connected over time. You just do not know. It's non-injective. You do not know how to get back to the time information because it wasn't in the data in the first place. So if a mediator variable in cross-sectional mediation statistically accounts for large amounts of the age-related variance in the dependent variable, this does not imply that changes in the mediator correlate with, precede, or cause changes in the dependent variable. It also doesn't work the other way around. So if a mediator variable in cross-sectional mediation statistically accounts for 0 variance in a dependent variable, so it's a very bad mediator. It doesn't account for any of the age differences in the dependent variable. This, however, does not imply that changes in the mediator do not correlate with, precede, or cause changes in the dependent variable. So the simple message is, if we want to find out about change, we need to observe it. Which is why I now actually turn to change, because in the meantime, over the last 10, 20 years, a lot of change has been observed, so that you are now in a position to actually aggregate across studies and perform meta-analyses. And that's actually a data set that I would like to go in some depth with. This all goes back to a very old question, namely, what is the dimensionality of cognitive aging, or does it all go together when it goes? And in a nice paper in 2005, Dieter Deckert and Ulrich Meyer remarked, the ultimate answer to the question of whether cognitive aging is a general factor or multifaceted phenomenon will come from careful longitudinal data that allow for testing the dimensionality of change across a wide range of cognitive abilities. So you can get all these age trends, and you see that for many tests they are going down, but what you do not know is whether those people who show stability or decline in one measure are the same or different people from those who show decline or stability relative to others in another measure. That you do not know by just looking at univariate trends. So Elliot Tucker-Drobe had the lead on this, and Andreas Brandmeier developed some very useful new meta-analytic effect size statistics, and I had the pleasure of working with the two, which was really nice. We constructed a meta-analytic database, and of course what you needed is that there were at least 2 or more different cognitive abilities that had been assessed in a study, and that they used contemporary methods for modeling change, so latent growth curve or latent difference score modeling. So we only looked at latent covariances in that study, covariances of change. We excluded studies of clinical populations, studies of child and adolescent populations, even though that would be extremely interesting. And also made sure that the data were of a minimum quality in terms of avoiding ceiling and floor effects. And then we just collected what we got, and we ended up with 89 effect sizes representing shared variance and cognitive change from 22 unique data sets, which of course means that there is substantial nesting in the sense that more than one correlation of change may be present in a given study. And all in all, we had over 30,000 unique individuals. The longitudinal waves ranged from 2 to 12 years, and the longitudinal time lag distance between measurement occasions from 2.8 to 21 years, average age at baseline 35 to 85 years, and we had a total of 98 different measures, and you can see how they are distributed over the different cognitive abilities. We used multi-level meta-regression models that account for the nesting of effect sizes within samples that I've already mentioned. And we did effective error-based precision weighting, which accounts for time lag, number of waves, and magnitude of variability and change, which all contribute to the precision of estimates. And we also did a downweighting to account for the number of effect sizes that is contributed by a study. So the first thing that we looked at is variance in level. That means not variance in change, but just level in the intercept. Because we know that different cognitive abilities hang together at a given point in time. That's what's called the G factor, which I only use as a descriptive term here, not as an explanatory term. And what we can see is what you typically find, namely that about, in this case, 59% of the variance in levels is accounted for by a general cognitive ability factor. And you then can look at your meta-analytic factor model, and you can see that all the various abilities loaded on that general factor. Now, the question is, what about shared variance in age-related changes? Is there a common factor of change? And here you find the result, an average of 60% of individual differences in longitudinal change is shared across cognitive abilities. That means that the common factor of change is just as strong, just as prominent as the common factor for the levels. And you then also can look at the loadings, and you again will notice that there is actually a pretty high congruence between the loading pattern of the levels and the loading pattern of the changes. You find a very similar structure across these two parts of the data set. Now, one really interesting question is whether that common factor of change increases with age. Because if you think that these changes are operating over time cumulatively, then you would come to think that as the things that produce this common factor are increasing in strength due to senescent changes of the brain, for instance, that then the commonality in change should increase as well. So that basically the weight of this change factor, its common variance, does not remain invariant across adult age, but increases in size as people get older. And that's what's called dynamic de-differentiation. Dynamic because it refers to the changes becoming more common, having a greater common variance with increasing adult age. And this is what we find. So what you see here is the slope communality, so the amount of common variance in change. And you can see that that common variance increases as a function of the mean age of the sample we are looking at. Now, one objection by a reviewer was that this may be a mixture of people who later will become demented, so that it's basically a dementia confound. So we tried to address this by excluding probable or potential dementia cases from the sample in a very conservative manner. And dynamic de-differentiation was still reliable. So we do not think that what we observe here is just an artifact, if you wish, of the admixture of probable dementia cases through the analysis. Now, I think that this actually has some repercussions for a very prominent theory in lifespan development, namely GFGC theory. So there is this theory that states, and it's well documented, that those abilities that depend more on knowledge tend to be stable across adult age, whereas those that put a very strong demands on your current processing abilities decline with age to a greater extent. And this is called sometimes pragmatics and mechanics by Paul Baltus, or crystallized and fluid intelligence by Cattell and Horn. And this theory is correct as far as the average age gradients are concerned. However, it would be wrong to think that crystallized intelligence is somehow shielded from decline, is somehow exempt from decline, as if it was not happening in the same brain and in the same head as the fluid mechanics are. Rather, what is going on, and you can see that just by looking at the way in which the verbal tests load on the common change factor. It's not that they form some separate corner. They are as much part of the general change factor as the other abilities. A bit less perhaps, but definitely a strong loading. So what is going on here is pretty simple, and we are currently now showing this together with Lars Nieberg with the Betula data, and also with Elliot Tucker-Drobe with data from Atlanta. There are those people who show less decline in fluid abilities, and they actually show growth rather than stability in crystallized intelligence. And there are the other people who show steeper than average decline in the fluid mechanics, and they actually also show decline in the crystallized abilities. So these abilities are traveling in time together, and they just differ in the average gradient, but they are related through change to one another. Now, is this a bad message or is this a good message? Well, when Pat Rabbit said, does it all go together when it goes? He also could have asked the question, does it all stay together when it stays? And what you can see here is that, yes, not only does it stay, but it may also improve for some people rather than for others. Of course, at this point, I should also add that I talked about 60% of the variance and change and not about 100% of the variance and change. So there is, of course, place for specificity, but I think one has to understand that a relatively large portion of the variance is shared, so that it does make sense to look for common explanatory causes. Okay, so that's my interim conclusion that I just anticipated. And you may, of course, ask yourself, what could be a potential cause of coupled change and de-differentiation? And I actually think for a long time, together with Su-Chen Lee, that changes in neuromodulators may be a prominent candidate. Several neurotransmitters show consistent decline with advancing adult age, and decline is particularly pronounced for the catecholamines, for dopamine and norepinephrine, and they act as neuromodulators, which means that they have widespread effects on the operation of the cognitive system. Now, basically 20 years ago, we put out a very small connectionist model, a toy model, if you wish, in which we tried to simulate the effect of declining neuromodulators on cognitive systems. This is work that was led by Su-Chen Lee, and that built on work that before had been done by Savant Schreiber on schizophrenia, where they used the same basic idea, but actually when you go into the details, a rather different model compared to the model that we are using for aging. What we did is that we varied only one parameter of our model and then looked at what it does to the networks. And the parameter that we varied was the gain function of the sigmoid that relates input to output in artificial neurons in a simple connectionist backpropagation network. And so we assumed that in young adults, the gain function would be high, close to what we know are optimal levels. So we sampled randomly from a range that went from 0.6 to 1.0 in this case, whereas for the old networks, we assumed that due to depleted dopamine, the gain was reduced, was closer to the flat line, where you basically have no transmission of the signal. And in this case, we varied it from 0.1 to 0.5. So that's the only difference to the networks that we implemented. The architecture and everything else remained the same. Now, of course, if you assume that systems are operating in noise, what this means is that the signal is degraded relative to that noise whenever information has to be transmitted. With the simulation, we were actually able to mimic a lot of hallmark phenomena of cognitive aging. We found that if you do that, if you reduce the stochastic gain of the sigmoid function, you get an increase in stochastic stimulus unrelated fluctuation, you get less distinct processing pathways, and that brings us right into the present, you get less distinct internal representations. Now, at the time, we just could probe our networks and show that they had less distinct internal representations. What is so fantastic when you are a scientist is that in the meantime, science develops, and now by representational similarity analysis, you actually have a way of probing the distinctiveness of internal representations in the human brain. And then in terms of behavior, we got an increase in performance fluctuation, decrease in mean levels of performance, increase in inter-individual differences in performance, and also an increase in covariation between tasks across individuals, which is exactly what I just described as de-differentiation. Greater age deficits with more difficult tasks, greater proactive interference, and so on. I will be brief here. This is just to show you when you look at the units at the hidden layer, you have the young networks. You have a young network on top, an old network at the bottom, and then you have 4 different stimuli. And you can see that for the young network, the representation of these stimuli in terms of the activity of the 5 units is more different from one another than for the old network. This was an architecture that had 2 processing pathways, one for verbal information, one for spatial information. And by lowering the gain, there was more leakage from the part of the model that is for the verbal information to the spatial, and vice versa. So whereas on the left, you see the young network where you have these 2 parts of the network clearly separated. On the right, you see the old network where there is co-activation of the other unit, which you can see because now the activation is more in stripes, like on the diagonal. And this happened even though the architecture of the network stayed the same. Now, as I told you, we are now in the present, and in the present you can look at brain activations, and there is a famous finding by Denise Park. I'm sorry that somehow I skipped the reference to Park, I think 2004, fantastic paper in PNAS. And what she found is when she looked at, let's say, the face area, the fusiform face area that we know is activated when you see faces. And she looked what that area does when you look at houses. She found that the difference in activation, faces versus houses, was way smaller in old adults than in young adults, which means that the face area was less selective in responding exclusively to faces and not to houses in old adults compared to young adults. And she found exactly the same finding when she looked at the way the place area, parietal place area reacted response to houses. So there was relatively more face activation in the house area in old adults than in young adults. In a recent study, Miriam Sander and others did an incidental encoding task, again with faces and houses, with a Bayesian block of jittered stimuli as a control. And then, in addition to that, also did a recognition test where you later have to decide whether a given house or face was old or new. So now you can actually look at whether the distinctiveness of memory representations is correlated to memory performance, which is something that had not been done in the original study. What you can see here is that there was a face cluster and a house cluster very similar to Denise Parker's work, and you then can compute a neural distinctiveness score, which basically expresses the difference in activation for the preferred minus the non-preferred stimuli averaged over the two areas. So once looking in the face area and seeing how much faces are preferred, and then looking at the house area, seeing how much houses are preferred. And what you can see is that this neural distinctiveness score is reliably lower in older adults than in younger adults. And what you can see as well is that this neural distinctiveness score is actually related to memory performance. So those who discriminate the categories better are also better able to later on decide whether a given face or a given house was old or new. In the next step, Miriam Sander and Malte Kobelt and Verena Sommer and Attila Kirstedt and Markus Wergle-Bergner asked the question whether the degree to which a given representation is similar to itself over time relative to how similar it is to all other items from the same category. So how similar is an activation when you get a house represented again, same house, to all other houses that were in the list? This is what they called representational stability. And they found areas in the brain, not in the fusiform face area and the parietal place area, but more in occipital regions, where younger adults showed higher item level representational stability than older adults. They did not find it the other way around, only in favor of younger adults. And when you then look at this item specificity score, how high is the self-similarity relative to the similarity to other items, you again find that it is related to memory performance. And I must say I'm extremely excited about this work because I think it tries to really get at the notion of neural de-differentiation in a very specific manner that really tries to look at the fate of individual representations over time. I will speed up a bit, list a few future challenges, and then end with concluding remarks. Future challenges. This is especially for the fellows. I mean, for the fellows of the LIFE program, because I think there's so much to do, and we can do so much better. We understand the fundamental limitations of cross-sectional designs, but how often do we collect multivariate, multi-level longitudinal data? And of course, I hear all the ways as yeah, but the funding, and I know it's hard, but it's really what we would need to do, at least more often. We know that elapsing time as such does not cause anything. And again, Ellen Hammaker talked about this. But do we actually model data as a function of the mechanisms that we think are generating the behavioral changes we are interested in? I mean, all the beautiful longitudinal growth curve work that we are doing is not about generative modeling. It's about trying to fit a shape that looks like the shape you observe, but it's not trying to generate the shape based on first principles, based on having understood the system. And of course, it would be great if we have a general move toward generative models of change. We like to use the word dynamic when conceptualizing the development of brain and behavior. But how often do we actually try to capture the dynamic properties of variability and change? In theory, we take a multivariate view on neural activity, but how multivariate are our analyses of functional brain imaging data? Now, I must say that I have become more optimistic regarding this one, because I think what has happened during the last 2-3 years is just fantastic in terms of moving away from mass univariate analyses to really more network-like multivariate analyses. So I think it's happening. We conceptualize development in terms of levels of analysis. But how good are we at measuring each of these levels and interconnecting them, like from animal models where we can observe single neurons to mass action to behavior? We need statistical and computational modeling to render our theories of variability and change precise and testable. But how often do we actually use models to parameterize and test theories? Now, there was this beautiful talk by Daniel Bassett where she actually did exactly that and looked at whether there are privileged structures of knowledge that we are better at representing compared to others. And as she also mentioned in her talk, that you could think of this work easily from a developmental fashion, namely, how do these biases or priors develop for structuring the world, develop as we grow up. Concluding remarks, I would like to thank all the scientists at the Center for Lifespan Psychology. These were the ones who did the work on the coupled change. Martin Löfden has worked on this exploration, selection, refinement model of plasticity together with me over the last years. And these were the people who are currently doing the neural distinctiveness work that I mentioned at the end of my talk. And then I also would like to remind you that it happens that Paul Baltus would have turned 80 this year. So I thought I could also conclude with a note on things that I have come to appreciate, if you wish, mottos or maxims while working with him first as a student and later as a junior colleague. So I just wanted to list a few things that I thought were remarkable in the way he collaborated with others. And here we go. Trust is the most powerful and gratifying resource. Be unpredictable in your ideas. Be reliable as a friend and colleague. Do not get lost in details, but know about them. At some occasions, being precise is good. At other occasions, remaining vague is actually better, conceptually, and as he would have pointed out, strategically. Love complex thoughts and simple experiments. Both people and institutions deserve respect. In every loss, identify the gain. All forms of conceptual and methodological imperialism are suspect. This one, I think, is especially important. 1 hour of imagination and discussion saves you 4 weeks of pilot studies. Share success, not failure. Contradictions announce insight. Enjoy them. Don't follow others. Value their skills and learn from them. Think ahead and look behind. Try to see the big picture. Put faith in your students' potential. Work hard and enjoy life. And work hard and enjoy life is something that we in the LIFE program were used to be doing twice a year at our academies, where we met and didn't have to think about social distancing here overviewing Zurich. And I just hope that we will soon be able to do this again. I mean, just sit around and chat and not having to worry about whether we might have a super spreader among us. Nevertheless, it's wonderful that we can do it this way as well. And on this note, I would like to thank for all of you who made this possible. We have the speakers and the ones who introduced them, and I didn't know that Lisa would be introducing me, which is why she's not on the list. We have the moderators, Thorsten Pachur, Miriam Sander, Nico Schuck, Markus Wergle-Bergner. We had fantastic IT support. We had a layout team that invented the orange background and the flyer. The mastermind behind this was Markus Wergle-Bergner, who actually took the initiative and suggested that she should do this, and then teamed up with Imke Kruse and me in making it possible. And last but not least, we have Silke Schäfer. She is the one who coached us through these sessions, and I know that for many of us it was the first time of doing this with such a large audience, and she would make sure that things go well, and in fact they did go well. So my last thanks go to Silke for making it possible. And that's the end.
Thank you, Ulman, for this very broad and integrative presentation, especially for wrapping up all the ideas that were presented during the lecture series over the past 10 weeks into your presentation and integrating them in the broader lifespan perspective. As usual in our sessions, also today we start the question and answer part of the session with fellows first. So we would reserve the first 2 to 3 questions for our fellows, and will open afterwards for the general audience. Again, if you have any questions, please use the question panel in your GoToWebinar control panel to indicate that you would like to pose questions. And now we would like to start with the first question by Anna Thoma.
So thank you very much for this great synopsis. I've actually been thinking a lot myself how you can increase to collect more longitudinal and multivariate data. So in especially experimental psychology, the second best proxy of between person differences for change is quite frequently used to suggest some kind of individual trajectory. And I've been thinking about how to tackle this problem. And my question is, how can we raise awareness that between person differences is not the best proxy for change? And how can we incentivize to collect more longitudinal multivariate data?
Yes, I think one change compared to 20 years ago is, and I know that I'm not answering your question, is greater availability of archival data. So what I see more and more as part of the open science movement is that it has become not only commonplace, but almost good practice and an expectation that data are shared. And this, of course, opens up a vast array of existing longitudinal data. However, these existing data, of course, have their weaknesses. For instance, they do not use the methods that are available today. So I think what needs to happen is that we build a more stable infrastructure for science through large consortia, by working through the European community, in order to get an infrastructure for longitudinal data acquisition that is more robust and not so much at the mercy of current funding situation. That's one answer. The other answer, the other one, of course, is what also Candice mentioned in her talk, is to make people on the street, in the sense of citizen science, be members of your team, so to say. So they produce data all the time, and it's accessed by Google and by many others. And if you really think that the concept of informational self-determination is a good one and should be a real one, then they might also be willing to share their data with scientists. I see it all the time with the older adults in the Berlin Aging Study. For them, contributing to science is a real value. So if they understand that we are not exploiting them and that we are not after their money, but we are actually trying to understand how they live their lives individually, and perhaps also how we may help them to make certain things easier or more effective, then I think that would be a fantastic data resource. But that, of course, requires a society based on trust and a high degree of civility, so to say. So I think it's a larger endeavor. I don't know whether I answered your question at the level you wanted me to answer it, or whether that
yes,
was too general.
Yeah, thank you very much.
Thank you, Anna. The next one on my list is Colleen Frank. And afterwards, we would like also to open the floor for questions from the general audience.
Hi, thank you so much for your talk, and Marcus for organizing all of these lectures. They've been really, really useful. Ulman, you said that if we pushed you on the difference between qualitative and quantitative, it's not really a dichotomy, and I'd be really interested to hear in kind of your thought process behind that.
Yeah, sure. The example that I like most is a Piagetian example. So I do believe that there is a qualitative shift in thinking whenever a child is able to combine two premises to a conclusion, such as, for instance, A greater B, B greater C, therefore A greater C. I think that this therefore is really a big step, and it comes with a new feeling, which I find fantastic. I mean, the feeling of necessity. So the same child half a year before may not have been sure, or perhaps it's like this, perhaps it's like that, and half a year later, he or she will ask you, how can you even ask? It's clear. If A is greater than B and B is greater than C, then A is greater than C. Okay, so let's call this a qualitative shift. However, it's pretty sure, and there is also the math to go along with it, such as catastrophe theory and other kinds of dynamic system theory, that you may have some quantitative variable that is changing in a completely continuous manner. For this time being, let's call it working memory capacity, which probably doesn't exist as a little box, but let's just call it this way. That at some point allow you to hold these three things in mind at the same time. So you do have a continuous change that allows for a qualitative difference. And in this way, I often think that whenever we use the word qualitative, we perhaps should try very hard to find the continuous variables that underlie the qualitative change. And in that sense, I do think that nature probably doesn't make jumps, or that the jumps it makes are based on variables that tend to be continuous.
Thank you.
Thank you, Colleen. We have the first question from the audience, and here we have Rick Hansen.
Hi, Ulman.
Hi.
Can you hear me?
Yes, I can hear you.
Greetings from Cambridge.
Thank you.
And firstly, thank you to Marcus and the team for organizing these talks. I've learned a lot from them over the last few weeks. Regarding your talk, Ulman, I had a question about your meta-regression on dynamic de-differentiation.
Yes.
I suspect it's too difficult to go back to the slide, but I have a clear image in my head, and I suspect you have a clear image in your head too. But it looked to me like the positive linear slope was driven by about 4 studies that started with the very young age of 40 odd. And my question is, are there anything unusual about those 4 studies that started, cohorts that started earlier? Or if not, is it possible that the de-differentiation is exponential, asymptoting in old age, so that the critical period is middle age when these things de-differentiate?
Let's just, because it's actually a little bit more complex, let's just, is this the one you are talking about?
Yes.
Do you see?
Yes,
great.
I do. And regardless of whether you remove the dementia cases or not, in both cases, the linear fit looks driven by the 4 studies on the left.
I think we
imagine removing those. I think the slope would be lower. But this is not just a nitpicky question. I'm sure those 4 studies are reliable given the small circle size. I don't know if that's precision or sample size, but in any case, let's assume those 4 studies are valid. It would suggest that the de-differentiation is happening rapidly in middle age and possibly slowing down in old age.
I think the verdict is open.
Yes, I mean, it's a question of
because I'm lacking studies between 40 and 50. I would need to ask Elliot whether he ever ran the analysis taking these 4 points out. But let's assume that he did it, and let's assume that it remained reliable. There is no doubt that it would bend downwards, that the effect would be weaker. That's clear. And so what you are saying is that dynamic de-differentiation may be something that is going on, let's take up to age 70 or 65, and then it flattens.
Yes. So is middle age critical here?
Ulman, sorry,
yes.
We have Elliot on the audience, and he may have an answer to these questions.
Yes, sure. Elliot, jump in.
So yeah, we observed the same thing. It's difficult with these scatter plots that have weighted effect sizes to really visualize what the kind of scatter cloud looks like in the same way you would when you have unweighted effect sizes. So we were particularly interested in whether or not that regression would be obtained if we removed those 4 points that seem to be providing a lot of leverage. One thing to keep in mind is that those points are very small, which means they provide very little leverage. They weren't weighted very much. But actually, what I had just pulled up is the figure caption for that paper. And the answer is that the positive association between slope communality and mean age at baseline remained when restricting the analyses to estimates derived from mean ages at baseline greater than 50. So that would remove those 4 points and I think the 3 points just above 50. And then for the dementia controlled analyses, the positive association also remained when restricting the analysis to estimates derived from mean ages at baseline greater than 50. And we provide the p-values and the slopes, but generally speaking, we see the same pattern.
Yeah, but is the slope reduced? I mean, I appreciate this is kind of glass half full, glass half empty. You can look at it both ways, but it might be interesting to know whether this is actually an exponentially decelerating process, that de-differentiation happens at a certain point. I know you can't tell that from these data, but it's something you can test.
Rick, I would say in the limit, it probably has to be decelerating because you cannot get higher than 100%, right?
Sure. Yeah. Well, it depends what it starts at.
Yes, I understand. And it would be interesting if it starts saturating before it reaches its potential maximum of 100% shared variance. And then you would have a decelerating dynamic de-differentiation. That's true, and I think one probably would need, but it's a very difficult question because as we move along the age axis, we also have a selective attrition.
Yes.
So we are comparing the survivors to the non-survivors. So I can imagine certain scenarios where dynamic de-differentiation may slow down, but let's put it this way to come back to what Elliot said, there's nothing in our data to suggest that this is the case.
Yeah, I wasn't asking just to be nitpicking. I was actually asking because I'm interested in whether middle age is an important time period for a lot of these aging processes. That's why I'm interested in.
And with that, I would totally agree. I mean, and data, I mean, you being part of the LifePoint consortium, you know these data as well as I do, and there's certainly data, for instance, from Betula looking at what's going on in middle adulthood as a function of performance in old age that speaks to the critical importance of middle adulthood. Yes.
Thank you.
Thank you very much. Given the time progressed, I would like to come to a close with the session today, and again come to an end with the live theory 2020. And it couldn't have been better than having such a lively discussion and already new ongoing questions that one could address in the future. I would also like to thank all contributors to the live theory lab. Again, for us, it was the first time we organized such a virtual lecture series. We learned a lot on the way, and we are already thinking about pursuing this endeavor in one way or the other over the next years. And we hope that you would be able and willing to join us again for one live theory lab, maybe 2021 or one of the following years. With this, have a nice day and stay healthy, and see you soon for the next version.
And thanks again, Markus and Silke. I really appreciate all the time and effort that went into this.
You're welcome.